Sketch-based user interfaces have been successfully used for cutting meshes. One type of UI allows the user to draw strokes to specify the foreground and background regions. It seems unnatural that the user needs to specify the background which he does not want to cut out. A more recent UI allows the user to draw strokes across a designed cutting boundary. However, the user has to know where the cutting boundary is. We present a novel mesh cutout tool called Paint Mesh Cutting for interactive mesh segmentation. The user only needs to draw strokes on the foreground region to get the design cutting part. Specifically, the user paints the foreground with a brush while holding the left mouse button. The user then can continuously drag the mouse to expand the foreground. The user can progressively paint the region of interest and have the instant feedback on cutting results as he drags the mouse. The user does not need to paint over the entire area since the foreground can be properly expanded from the brush to the nearby part boundaries. We rely on a volumetric shape metric called shape diameter function, SDF, to distinguish the different parts of the shape and use Gaussian mixture model, GMM, to fit the statistics of the SDF values of the shape. The heart of the technique is minimum graph cut optimization based on GMM and SDF of the shapes. Once the segmentation process is triggered, we apply a progressive segmentation algorithm. Graph cut optimizations are performed on the local regions, and thus the expanded foreground region is computed in a very short time and is instantly displayed to the user. A boundary optimization based on snakes is performed to optimize the cutting boundary after the user releases the mouse. An initial global optimization is triggered to get a foreground region when the user starts to paint the brush. Then local optimization is performed continuously to expand the foreground when the user drags the mouse. After the user releases the mouse, a final global optimization is triggered to get the final cutting result. Our Paint Mesh Cutting tool can work for various models. In this example, the user paints a few more brushes to get final foreground regions. This is a mesh with complex topology. Our tool can cut out the subpart with high genus. Our approach is insensitive to noise. We add a certain amount of noise on this mesh, and our approach can still get the correct cutting result using the same paintbrush. The user can paint the brush freely over the mesh. Our system can obtain reasonable cutting result even if the user cannot express himself well by painting the brush. Our approach also works for cutting thematic patches from the mesh. Our system allows the user to switch between part brush and patch brush easily by pressing a button. Here is another example. Here we show a complete segmentation example which illustrates how our tool works for cutting different parts or patches on the mesh. Here's another example produced by our system. Here are more segmentation examples produced by our system. In conclusion, our new user interface embodies the motif "what you paint is what you get" and provides a more intuitive and natural manner to cut meshes. Thank you.